me show one B bar. Huh? There's a B bar. So after some time, the particle will arrive here, no? With what speed it was projected? With the speed v sine theta only. So after some time, it will be it will be available. So call that as say some v naught or something, any velocity, or let me call v1. Then how we define all other quantities? This should be the thing. So here, write down like this. So this distance is, so how much angle it will rotate? It will rotate through an angle, theta. No, magnetic field should be out of the plane, no. Positive x-axis.
Sir, that means it should be into the plane only, no, sir?
Oh,
Cross symbol we should keep.
out of the plane, no, here, this diagram only. B bar along positive x-axis. Where is the positive x-axis? Should be out of the plane.
Okay.
Okay. So previous class what we defined. So you call this center C. Let this be origin. Let this be the point A. You pick up with this. So what is OC equal to AC? OC equal to, or CO equal to CO. CO is equal to CA. This should be equal to radius of the circular path R, which is equal to mv sine theta by qb. And we know q by m, we write it alpha, no? So v sine theta b alpha, you write it. Then, so can we write this? What is the coordinate of this one? Y comma minus z. So what is y is equal to r sine theta? So what is the coordinates of this point will be y comma minus z. So what is y is equal to from the triangle? This is y, I'll write it. And this should be the z. I think I have many parameters to show here. So what is this? This will be z. Of course, negative value minus z it is. Okay, let's write here. What is y is equal to r sine theta? This is r. So sine theta equal to y by r. What is y equal to? R sine theta. What is r equal to? V.
Okay, theta is also the angle of projection.
Okay, this is some phi, I'll write it. Phi will make it. So, some other value will take it. Yeah. What is the value? This will be v sine theta b alpha equal to sine phi. So at t equals 0, it is here. After some time t, it is available here. So can we define omega as phi by t? Further phi, what you can write it as? Omega t. This one. And omega, what you can write as? bq by m. Is that okay? So omega should be bq by m or b alpha. In short, I'm writing that one. It's independent of speed of projection, no? Okay, no phi, you can replace it. So this should become what is y is equal to v sine theta b alpha sine of b alpha t. I got the y coordinate. Similarly, I want z coordinate. Z coordinate should be what is z should be equal to? Z should be equal to CO minus the distance. CO minus r cos phi. Try to look at the triangle. Shall I magnify or is it sufficient? If you are able to see clearly, okay, then I'll continue. So what is this distance will be? So or we'll have the triangle. I'll write all the things. At least looking at this triangle, you can write it. So we want to just, well, of course, z is negative. Later on in the position vector, I'll write minus z. Now let me call the distance as z. O, A, B, C I took. Okay, let me write D. I think CO minus CD. CO is what? Is equal to R. CD is what? R cos phi. So R into 1 minus cos phi is what? B alpha T. I got the Z coordinate. So finish all. See everywhere the same story. Like yesterday, what I did, the same thing I'm repeating here. Little bit the orientation of diagram changed. The B bar, all that one. So what about the X coordinate? How to bring X coordinate? Along x-axis, what type of motion? Uniform velocity motion. Everywhere it will have constant velocity v cos theta. In yz plane, it will have constant speed v sin theta. Along x-axis, it will have a constant speed v cos theta. So I'll write it in yz plane plus or minus y minus z plane. Speed is how much? V sin theta. Along x-axis, what is the speed? So there's a very basic problem it is. If you can understand one problem, you can manage. Along x-axis, because there's no external force, no, so v cos theta will remain same. V sin theta in y minus plus or minus y minus z plane, it will remain constant here. So therefore, what is x coordinate? We can write it directly. X coordinate should be equal to speed into time. So now I'll define position vector xi cap plus yj cap minus z k cap. I should write y minus z. I think the particle can never be on, will have positive z coordinate, no? So during its spiral path, it's going to revolve only in that it will have minus z coordinate. What is the maximum possible value of z coordinate? Minus 2r. What about y coordinate? Plus or minus r. It can never enter into this region. It is going to revolve here only. And it will come out of the paper. So here is what? So here the particle will be revolving. It will describe helical path. It will never come z coordinate, but the diagram here, it appears as if it will cross through z coordinate. So try to, that's why I just gave plane diagram. Look in the right hand side. The particle can never come here, no? So therefore it should be minus z k cap only. Why will spiral path? It is describing spiral path. Okay, I'm showing that practically I'm seeing that it's describing spiral path, and for that mathematical equations I'm bringing. No need to do any research work here. Okay, got this. So substitute all the values of x, y. So x equal to v cos theta t I cap. What is the value of y? Y is equal to v sin theta b alpha sine of b alpha t minus this will be v sin theta b alpha 1 minus cos of b alpha t. This will be k cap. Okay, this is a position vector of the particle. Is that okay? So at any instant of time, sir, what is the position of the particle? As substitute that t, you are going to get this one. Similarly, I want velocity vector. How to bring velocity vector? I want velocity vector.
Differentiate.
Or directly, you know, in yz plane. So here come this one. So how much of it will, speed will not change, no? V sin theta only. If this is phi, this is phi. So if this is phi, so here this should be the phi. The vertical should be phi. So therefore, the x-axis will be v cos theta I cap along yz plane. How you write it? V sin theta cos phi. V sin theta cos phi. I think I have to give one small diagram. There's a charge particle. Here is what it will have. V sin theta. This is phi. This will be phi. This will be phi. Okay, this. So there's a point, you know. This is the center C and this is the origin. So this is what is the direction? This is y-axis. And this is the minus z. This is plus y. First you define the v bar. How you define v bar? Along x-axis. Vx I cap here, vy j cap plus vz k cap. Here minus vz. It should be component of course it will change. At one instant it will have even negative also. For a given instant of time we are putting that one. So better write this is plus here. Okay, now write it. Vx is equal to what? V cos.
Directly differentiating.
Or you differentiate. I'm better to learn this also method. So this will be V sin theta cos phi j cap plus this will be V sin theta sin phi k cap. Theta is given for us, whereas cos phi is not given. What is cos phi? You can write it. Cos of omega. Omega is further b alpha t j cap.
Minus, sir.
At one instant, it will when particle is here, what is the direction of velocity? Will be positive also, no? So therefore, the time will determine whether the velocity will be positive or negative.
Sir, minus k cap, sir.
And this should be, no? Yeah. This is minus k cap. I write it. And it need not be always minus k cap, because sign can be positive or negative. So it all depends on this one. So this is t equals 0. This is a time t. So when a particle moves in helical path, do we know position vector of particle? Yes, this is a velocity vector. Fine. So this is the basic mathematical thing what a student must have, like how to predict the position vector and the particle and the velocity vector of a particle moving in helical path. So what is the basic methodology? The methodology is like this. I think the total diagram I'm showing it here. What is the basic methodology here? First, that helical path you break up into plane diagram. First, the plane in which it is going to revolve in a circular path that you identified. Then the axis of helix. Identify that, get the radius of the helix, time period of the revolution, then the pitch of the helix. If they ask you something like a velocity or the position vector, no, so take help of this plane diagram. There will be a better idea. Okay, now we'll take the next some cases. Now, if there is a electric field vector is there,